Today I thought I'd try something different, a little bit old school. What I'm going to try and do is fire up this boy, which is my breadboard CPU, obviously inspired by Ben Eater. So this was my first electronics project around 4 years ago. It's expanded upon Ben Eater's design. I've got 4 registers, 256 bytes of RAM, another 256 bytes of program memory. I did add a Wi-Fi program loader, which is currently missing, an LCD also missing. Looks like there's a few pieces missing. I did have a controller as well, which has all been hijacked, I guess, for my HBC 56 project. So I haven't fired this up in around 3 years, so I'm pretty curious to see what it takes to get this going. Breadboards are notoriously, flaky, so I don't expect it to work out of the box. Obviously, I do need to replace these parts, so let's find out. I guess we'll find out together. So right off, I can see the data dip switch here is missing. So this is the address one. When I was building the HBC 56, most of the cards that I built when I was doing the hand-wired cards had these dip switches used to pick basically the device port number. So when I built many of these cards, and I would have ran out of these dip switches, so pillaged from the old breadboard PC. But I've got a whole bunch of them now, so I'll just take and replace. So these are mounted upside down, just like Ben Eater's, and the reason for that is because when these are closed, as in connected, they're connected to ground, which we want to be low, as in down the bottom, because it makes it easier to do ones and zeros, as in 0 low, 1 high. So we've got one of those in. So the other things, so I had a programmer here and I had an LCD here. I won't put those in immediately. So this is the programmer, because this connects via Wi-Fi, and I'm sure my Wi-Fi details have changed in 4 years. Also the secure key when downloading from HTTPS has likely changed as well. So I'll need to update the code on this, which I'll do shortly. Also the LCD, so that plugs in like here somewhere. I won't put that on yet, we'll try it out without that. So reset, looks like the reset button's gone. Similar thing, I would have pillaged it for the HBC. So let's just grab another one. So I connected these with these turn pin headers just to make a better connection in the breadboard. So these are the busboard BB830s that Ben Eater recommended, but some things just, they hold in better with these turn pin headers, I find. So I've done the same with the dip switches here. There we go, nice and secure. So that's a button on turn pin headers, and clip him in. But yeah, that works really well. Looks like for the most part we're pretty good. I haven't stolen any ICs by the look of it. So the other thing is this register D. So this is the actual register here. We've got the transceiver here. When I made the Snake game, I made that little handmade controller. Since then, I think I made a Nest controller for it as well, which was plugged into a breadboard up the top here, and that plugged directly into register D. So what I did was disconnect it from the register and plug directly into the transceiver. So whenever I read from register D, the transceiver sent the data this way onto the bus. So what I need to do to enable register D is rewire this and also wire the transceiver to the ROM data. And the idea is then I can plug in the Nest controller at a later time. So the other thing is the power. So I used to have a barrel jack like one of these, wired to some pin headers, which was plugged on here somewhere. So now I'll just use this homemade breadboard power adapter. and that plugs on here, and luckily it fits. Move that pot out of the way. Alright, pretty cool. So I'll wire that up to my benchtop power supply here. Alright, so I've got my power supply limited to 1.5 amps. If from memory this drew about 1.2 amps. So let's turn it on and see how we go. Alright, no smoke. Got some lights. I can see it's in programming mode here, so I'll switch that. 1.2 amps, close to 1.3. Mode. Yeah, so it's run mode, clock's not running. Okay, we'll go automatic. Cool. Alright, well that's a good start. Let's just slow that clock down a bit. Yeah, looks good. Program counters going sequentially. Instruction register. So the green light here is when we're reading from the program memory versus the RAM. Obviously it's just running whatever happens to be in the RAM, just random data. As expected, the display isn't working. I do have so this is wired to high. So we've got FF, which is obviously -1 in unsigned mode. In sign mode. And yeah, that's hex mode and unsigned mode. So let's stop the clock. So I think what I'll do, I'll get my my Wi-Fi programmer working and see if I can download a program onto the breadboard. So first I'll head on over to the GitHub page, which is used to host all of the code related to this project, and clone it to my machine. Then I'll head over to the site which hosts the assembler and the emulator for this CPU, and grab the certificate fingerprint and paste that in, and also update my Wi-Fi details, and rebuild that and send it to the programmer. So then I'll head over to my online assembler and pick the bit rotate program. So that just rotates the LEDs in register C, as we can see here in the emulator. And then I'll submit that, which will make it available to my Wi-Fi programmer to download. Okay, so this gets powered by the breadboard, so that should work. Let's try it out. It's loading. Doesn't look right. Let's reset. No. Okay, not a good start. Oh, there we go. So something a bit flaky, but not too bad. Reset. Up here. Reset. Oh, no. Interesting. So yeah, there's something going on around here. Reset. So the program looks to be running correct. It's just the registers of bus. Something. So it looks like it's a bit unstable, or there's something going on with it. I think I'll break out the scope and see what I can see. So first I've got this ground clip that I made, which I can use to connect the oscilloscope ground allocator clips to. So I'll just plug that into a ground line there. So I think first I'll examine the clock. That probably makes the most sense. So I'll start the clock. And I can find that here. Okay, so that's looking really good. We've got a 50% duty cycle roughly, 500 Hertz. Obviously I can turn that up. Oop. Okay, yeah, so when we turn it up, it looks like we've, the duty cycle's a bit out, but given how slow this thing is, I don't think that's going to make too much difference. We'll turn it back down. Okay, so I'm wondering if I'm going to stop the clock. So if I restart the program loader, I should see a burst of clock activity from the program loader as it loads a program. Yep. Oh, hang on. So that was another burst? I'll just let it sit there. Yeah. Okay. So it should only load once. Oh, and again. Okay. So the program loader works by taking over the bus and the clock and memory. Oh, there it goes again. Memory enables and whatnot. And it loads a program via HTTPS and compares it to a program that's already loaded. If it's the same, it doesn't do anything. So either the program's changing or there's something buggy about the program loader. I've plugged the ESP into the computer and I've loaded up the source code into Arduino IDE. 2019, so it's been quite a while. What we'll do is disconnect the serial monitor and we should be getting some output there. Okay. Yeah, so immediately I can see that's not right. So we're trying to connect to this URL to download a program, and the program should be in hex, well, ASCII characters, a hex representation of the program. And here we've received server light speed. Which is 9 bytes, and now we've received a bunch of nothing. If I go to this URL here, and you'll see what we're supposed to be getting. Yeah, so that's the program in hex bytes. Which is this program here. So for some reason that's not what we're getting. Oh, here we go. I wonder did it work? I'll have to check the footage after, if it actually did work when it loaded that program. Okay, so if we go down to the bottom here where it does the request, and we can see it connects, it skips through the headers, and then reads the HTML content. Wow, okay, and we're getting header text in here, so it looks like it's not completely reading the headers before it's attempting to read the program. So, I wonder if that's the right thing to do, connected. Because it's possibly disconnected by the time it gets through here. But the text might still be in the buffer. If I change that to this one and upload that. It's quite slow to build an update. Okay, so we're going again. Connecting, that's my IP. Alright, that looks good, that's a program. Yep, and we can see the program running on the computer, looks good. Now this looks better, so it's receiving the same program each time, and as we can see here, if the program hasn't changed, it doesn't attempt to load it. And so we can see the program is running quite stably on the breadboard computer. So let's try and change the program. So if we change the pattern here, so, and then submit, and then hopefully I'll just switch back to the program loader. Once it polls again, it should check for that and see that it's changed. Ah, had to assemble. Silly. Alright, let's try it again. Oh, straight away. Okay, great. So we can't do much else in the way of test program until I hook up register D. Or perhaps I can try my luck with the LCD. Okay, let's do that. I'll just switch and upload a Hello World. Hopefully it doesn't use register D. Doesn't look like it. Assemble and submit. Okay, and obviously I need to plug in the LCD screen. I'll just do that quickly. My LCD is just this standard 16x2 with pin headers on the back. To get a bit of height, I've actually got this stack of pin headers. So I've got these turn pin headers to stick into the breadboard, and then just the regular pin header to get the additional height. Plug that into there, and hopefully get the right position. That's it. Beauty. Okay, that's amazing. Contrast looks a bit poor. Let's see if we can do something about that. So if I remember, I've got the contrast coming out here to this jumper. Yeah. Okay, I'll just find a pot to put in there. Okay, so here I've got a 10K pot. And there. Okay, that looks about the same. So I'll just adjust it. Yeah, that looks better. Nice. Okay, so we've got the screen working, the program loader working. Let's see if I can change that program. There we go. Nice one. Alright, let's try the classic bouncing ball. Looks promising. I'll just turn up the clock. Nice one. It's a bouncing ball. Now, for those who don't know too, my online assembler also has an emulator attached. So I'll just show that. So it's the same, instead of hitting submit, you hit emulate. And we can turn up the clock here. There we go. Looks just like the real thing. So I think that's a good time to end this video. Stay tuned for the next one, where I'll wire up register D, I'll add in a NES controller, and I'll get the classic Snake game fired up on the character LCD. Thanks for watching, and we'll see you on the next one. Cheers.